All right, hey, so today what we're going to do is we're going to do our last new lesson before we start reviewing for our test. And this is going to be on interpreting slope and y-intercept given a line of best fit. So we're basically going to be just adding on a little extra, basically just kind of fine-tuning the skills that we already have. So this warm-up is on page, it's not going to be 193. Oh boy, this is going to be fun. What I want you to do is look for warm up 431. I'm thinking that it's going to be probably page 129, because I think our homework last night was 123 through 125. So try like 129, 127 and take a look. So this is our example. It says a top fuel drag race car, so like a really fast race car, can travel 1/4 of a mile. So really, like if you want to think about it, it's like one lap around the track, like the school track, in 4 seconds. The dragster's distance over time is graphed below. The graph assumes a constant speed. You use the graph to complete problems 1 and 2, then use what you know about slope-intercept form to answer the remaining questions. So here's our graph, all right? And they gave us a line of fit, or a line on here. So the first question says, find the slope and the y-intercept. Well, to first find the slope, all you need are 2 points on your graph. So I got a point there, and you can choose any point that's a good point. Now you could choose that, but I'm going to choose this point, and I'll show you why. Because if I'm going to find the slope of this line, I don't want to go up, like if I went to these two, I don't want to go up 0.25 and over 4. I want to go up all the way here to 1. So I want to go up 1 and over 16. So my slope is 1 over 16. All right, now my y-intercept is where I start, is 0, 0. All right, that's your y-intercept. Now, the next step says write the algebraic equation of a line. Well, the equation of a line is y equals mx plus b. So our equation is going to be y equals 1/16 x plus 0, or just I would write it like this. Now, it says, what is the slope of a line with this? So let's just, before we go to 3 and 4, let's just talk about this. What does this slope mean? Because really this right here is today's lesson. Can you tell me what this means, your slope of 1/16, 1 over 16? What does that mean in the context of this problem? Well, since it's rise 1 and run 16, that means you are going to travel 1 mile in 16 seconds. So in words, it means you're going to travel. This right here means, all right, it means you travel, all right, you travel 1 mile in 16 seconds. That's what it means. Now, your y-intercept, all right, your y-intercept of 0, 0, well, what does that mean in the context of the problem? Well, 0, 0 means that's your starting point. So you start 0 miles at 0 seconds. So that means you start at the beginning. 0, 0 really doesn't mean anything, which is why it's really not in your equation. You know, you're starting at 0. There's nothing else. That's where you're at. So number 3 and number 4, they're just asking you about different equations, just random equations. So they give you this equation. So it says, what's the slope of the line here? Well, our slope is the number out in front of our x. So our slope is -1, or -1 over 1. For the next one, what's the y-intercept of this line? Well, our y-intercept is 0, -2. That's always your y-intercept. It's your constant. So this should be a review. But this part right here, putting words to the context of your line of best fit or a line, that's what we're going to add in today, which we've actually done in the past. So this is our target. We're going to interpret, that means give meaning to the slope and the y-intercept of a linear model in context of the data. We're going to also create some scatter plots. That's old. And then find the equation of the line that fits the data. That is your line of best fit. And we know how to do all that because we've been working on that all week long. So, come on, there we go. Now, it's not page 195. Again, look for this. Look for this up here. 431, example 1. I'm thinking maybe page 129 or 131. I don't know, something. Again, once you find the warm-up, then you're just going to be going with this. So, all right, so the example 1 says, the graph below contains a linear model that approximates the relationship between the size of a home and how much it costs. So how big your home is and how much the cost is. So the x-axis represents the size. The y-axis represents cost in dollars. Describe the slope and the y-intercept of the linear model in terms of housing prices. So here we go. Find the equation of the linear fit. So question number 1 says, write the equation in y equals mx plus b form. So we need to know our m. So our m, you want 2 points. Now look here. It starts at 0, 0. That's a great point to start at. Then, all right, if you look at all these, you're looking for good points on the line. This one actually does work right here. So my slope is going to be up 60,000 and over 300. So my slope is 60,000 over 300, which you're going to want to simplify, all right? When you, come on, computer. When you simplify this, the zeros cancel out, and 6, come on, buddy, why are you doing this right now to me? All right, so the zeros cancel out. So you get 600 over 3, which equals 200 over 1 when you simplify. So this is your simplified slope. This right here, 200 over 1. That's your slope. That's your slope. All right, now, your y-intercept, your b, is 0, 0. So if we're going to write the equation, it's going to be y equals 200 over 1x plus 0. So the units of our slope. Now our units of our slope are based on what our rise and what our run are. Our rise is dollars. So it's going to be dollars per foot. That's what it is. It's going to be dollars because you rise dollars, and then feet are your units. So it's dollar per foot. So our slope, what does the slope mean in the context of the problem? It means it's $200 per 1 foot. Or per foot, per 1 foot. That's what the slope means in the context. Now, your y-intercept, again, is 0, 0. So the units are going to be the same thing, dollar per feet. Okay? And the y-intercept means for $0, you get 0 feet of housing. Which makes sense. If you don't own any housing, you don't have to pay anything. All right? Having no house costs no money. That's what that means. So that's what we're doing today. Let's try one more example because this is kind of getting me a little frustrated. So here we go. A teller at a bank records the amount of time a customer waits in line and the number of people aligned ahead of the customer when he or she enters a line. Describe the relationship between the waiting time and the people ahead of the customer who enters the line. So what I want you to do, I want you to pause this video and I want you to put all these into your L1 and L2 and make your scatter plot. So your scatter plot should have people, and then this is minutes. Your Y is your minutes because L2 is always your Y. Okay? So I want you to create your scatter plot and then unpause the video and we will keep going. So pause it. All right, so this is what your scatter plot should look like. All right, and again, you put your scatter plot down here like, oh man, it looked like that. Okay, great. So now what we want to do, all right, is we want to describe the relationship between the waiting time and the customers ahead. So we want our constant rate of change, all right? So that means we want this to be a linear function, which it clearly is. So what we want to do is find our line of best fit. So we're going to go stat, we're going to go over to calc, we're going to go down to number 4, and then we're going to store it to vars yvars function y1. And again, depending on if you have the new calculator, you just have to store regeq. But anyway, all right, this is our linear regression. This is it on our graph. All right. And what we're going to do before we do anything, before we start analyzing anything, we have to see if it's a good fit. So we go second y equals, and we got to check the residual. So we're going to go to L2. We got to check the residual. So we go second stat, number 7. All right. And then zoom 9. So clearly the line of best fit is random. It gives you a random residual, which means it's good. So this is our line of best fit. So I'm going to write this out. So y equals, what is it? 4.36x, and then plus 11.49. Now my computer's acting funky, which is why the orange, so good thing this is our last one of the day. All right. So it says, describe the relationship between waiting time and people ahead of the customer. Well, that is your constant rate of change. 4.31 or 4.36 over 1 means 4.36, and this is your rise or run. So it's going to be minutes over people. So what it means is you will wait 4.36 minutes for every one person ahead of you. That's your waiting time. All right. You will wait 4.31 seconds for every person who's ahead of you. Now, this is interesting. Look at this. See this 11.49? Now, this is your y-intercept. This is where you start at. Now, this is 0, 11.49. Which means 0 is 0 people, and you're going to have to wait for 11.49 minutes. Does that make sense? If you went to a bank, if you went anywhere, does it make sense for you to have to wait 11.49 minutes if no one's ahead of you? No. So here's the deal. Your line of best fit is great because it matches your points. It's a good approximation to tell you what it will be like in the future. But sometimes you're going to actually have to think about it. Hey, you know, is that really true? If no one's in a bank and there's a teller waiting, will I really have to wait? No. But in the future, if like you're looking for like, if there's 5 people ahead of me, yeah, that y-intercept will play a part. So sometimes it takes a little bit of thought when you go through this and you think about, you know, what your y-intercept and what your slope means in context. But this is the big guy, that you're going to wait 4.36 minutes for every one person who's ahead of you in line. All right, let's take a look here. I guess we can do one more. So on the next page, example 3 says this. For hair that is 12 inches or longer, a hair salon charges haircuts based on the length according to the equation y equals 5x plus 35, where x is the number of inches that are longer than 12. So if you had like a 13-inch haircut, all right, 13 inches, x would equal 1 because it's 1 inch longer. 14, x would equal 2. 20, x would equal 8 because all I'm doing is going 12 minus that number, and that's what your x value is. So anyway, describe the slope and the y-intercept. Well, our slope is 5. All right, so what the slope is going to refer to is this is talking also about y is your cost. So what the slope is talking about is it's going to cost $5 for every 1 inch of hair. Oh boy, good thing this is the last one. God, I don't know why my computer does that. I think there's a virus. And the reason it's $5 for every one is because remember it's 5 over 1. $5 for every 1 inch of hair they have to cut off. All right, and then your y-intercept is 0.35. So that is 0, 35. And what 0, 35 means is For you just to come into that barbershop, 035 means that it will cost you $35 regardless if your hair is 12 inches or longer. All right, you are going to pay $35 for a haircut. So if you got really, really short hair, you're going to pay $35. If you got really, really long hair, well, you're going to pay $35 plus $5 for every inch that's longer than 12. So that's what your slope and your y-intercept mean in the context of this problem. So here's the deal. You are going to begin working on your homework. Your homework is in the book. All right, you're doing 1 through 10. I'm not sure of the page number, but it's gonna look like this. It's gonna say practice 431. This is clearly not the page. All right, but you are doing 1 through 10. All the answers are in the back of the book. Please check your answer. Please be good to the sub, and we will check this in on Monday. Have a great weekend.